Good day everyone! We are the Group 2 of STEM 11 to Y and we are going to present the application of Chatelier's principle.
The industrial process that we will be using in our presentation is the production of ethanol.
These are the members of Group 2 with their contribution.
Now let's talk about the significance, schematic diagram, the equilibrium reaction involved, and the application of Chatelier's principle to the process.
With the application of Chatelier's principle with the production of ethanol, it helps to produce a lot of useful things that make our living a lot easier than before. For instance, ethanol. Since it is a renewable energy made from various organic materials and chemicals, it produces fuel that reduces the emission of harmful gases such as carbon monoxide and even carbon dioxide. As a result, it is a huge help to our environment.
The significance of ethanol production is for the environment and for us living things, especially for human, society, and economics, as some of the commercial products that we use like beverages, perfumes, aftershaves, mouthwashes, medicinal liquids, rubbing alcohol, and other more contains ethanol. Its significance is also by making use of it to manufacture drugs, plastics, lacquers, polishes, plasticizers, and cosmetics.
Moving on with the schematic diagram of the process of production of ethanol, where ethanol is a renewable energy source. Sugarcane, corn, potatoes, cassava, and cellulose materials are examples of agricultural feedstock and agricultural residues, as well as forestry wood wastes. The molecular structure of ethanol is simple, with well-defined physical and chemical properties. Moreover, by adding ethanol to gasoline, the octane number in mixed fuels is increased, the distillation temperature is changed, and carbon dioxide emissions are reduced.
Production of ethanol. The fermentation process can produce ethyl alcohol from three different types of raw materials known as feedstock. The three different or basic types of feedstock are saccharine, starchy materials, and cellulose materials. Fermentation, distillation, and dehydration are the three methods of producing ethanol. Fermentation is a metabolic process that converts sugar to acids, gases, or alcohol. Ethanol is produced by microbial fermentation of the sugar, and distillation is a process of separating the component or substances from a liquid mixture by selective evaporation and condensation.
At the left side of the slide, we can see the diagram of the production of ethanol. The equilibrium reaction for ethanol is C2H4 plus H2O are in equilibrium with C2H5OH. Ethanol is manufactured by the direct catalytic hydration of ethene in the presence of steam, using phosphoric acid absorbed on the surface of a solid, silica, as a catalyst in a fixed bed reactor. The reaction is reversible and exothermic.
According to Chatelier's principle, this will be favored if you lower the temperature. Shifting the position of equilibrium is needed to produce the utmost possible amount of ethanol. A low temperature is needed to get as much ethanol as possible. The downside only is that the reaction will be slower if we use lower temperature.
The Chatelier principle became efficient to the production industry of C2H5OH or the ethanol, as the system will counteract the change imposed on a system of equilibrium. Since the Chatelier principle can happen through increasing or decreasing of concentration, heat, pressure, and volume. For the production of ethanol, there is a process called ethylene hydration.
In this process, the forward reaction of hydration ethylene is exothermic. According to Chatelier's principle, this will be favored if you lower the temperature. In order to counterbalance this, the system will shift its equilibrium position, generating more heat. The reaction is done at a temperature around 300 degrees Celsius. The efficiency of the Chatelier's principle is present as the process shows that both the catalyst and the increased temperature helps to produce ethanol that will benefit humans.
That would be all for our presentation. Thank you for listening.